But I keep coming across these different beam angles and how much spread there is in the beam. And we've had this discussion about how many actual rays of the sun would strike us at 93 million miles if the sun is a ball, and even one, quarter of a degree off, it would never strike the Earth.
Oh hey, it's Mr. Thrive and Survive. I haven't really looked at him much, but here we are now, staring right down the barrel of his special kind of stupid.
Bang! 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 Click, 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 click. No more bullets.
He says a lot and nothing at all, if you know what I mean. In this first video, Mr. Thrive and Survive takes issue with the beam spread from the sun and asks the hard-hitting question.
Who am I?
Hey everybody, we're Mr. Thrive and Survive. The experiments are coming soon with the sun angles and I'm going to be doing a 2-scale eclipse type of thing, and we're going to be doing the angles and everything. We found a gigantic sun that we can use. Mike Ball did a water tower that's pretty low to the ground and a lot of open ground around it, miles. So expect that to come soon.
I can't even begin to tell you where he's gone wrong here. But without even watching the video he's referencing, I can tell you he hasn't a clue how much light he would need to do a proper scale model test with the lights on a tower. And what it would cost. Now, I don't expect these guys to go ahead and do proper scaling when they do this, but let's pretend they do. What would it take to scale model the sun and the earth in just distance alone first? Saying nothing of light intensity. We're going to get there. So this is a great channel, simply called To Scale. They have a lot of neat videos, but many of you have probably seen this one in particular. See if I run afoul by using a couple little chunks of it.
If you look up an image of the Earth and Moon, you're going to get a picture where they're quite close together. Something like that. But in reality, the Earth and Moon are about that far apart. That is the Earth and the Moon to scale. There is literally not an image that adequately shows you what it actually looks like from out there. At this scale, the sun is 1.5 meters, so about that big around. So we are driving right now to Mercury, and we've arrived. I have the world in my pocket somewhere. And Earth.
So if you look at this, the Earth would be 176 meters from the light source with only a marble-sized Earth. Now let's get into light intensity for a test involving a mock sun to scale. We need to appropriately scale the light as well. So what do you think it would take to scale this light to be equal to the sun? Well, I did the math for him and I'll show you. So to do this, we need to first come up with some numbers. So here they are. A 1,000-watt metal halide will produce 120,000 lumens at 1 meter. Lumens on Earth are approximately 12,000 lumens at ground level. 1 candela equals approximately 12.57 lumens. First, we can take this equation for inverse square law and apply it to our numbers. Inverse square law involves light intensity and fall off over distance. We only need to solve I2 for the bulb, as we already know I2 for the Earth and the sun, as we know approximately how many lumens we get outside on a sunny day. So if we do the numbers with 1 meter and 176 meters, we get this. Now I'm tired, so I'm going to draw this like a child. Since I'm sure Mr. Thrive and Survive fills out his forms with washable crayons, this will probably be fine for him. First, we take 1 and 176 and we square them by multiplying them on themselves. That gives us 1 and almost 31,000. I'll be approximating while I'm verbalizing this. We then divide the 1 by approximately 31,000. We get 0.000322830, etc. We now multiply that by our 1 meter intensity of 9,547 candela that we got from taking 120,000 lumens and dividing it by the approximately 12.57 lumens per candela. This gives us a total of 0.308206 candela at 176 meters. So now we take the 955 candela that the Earth gets at ground level and we divide 0.308 into it to see how many 1,000 watt metal halide bulbs would be needed to make this kind of intensity. And the answer is 3,100 1,000 watt bulbs for a total wattage of 3.1 million watts of light energy. I'm not sure he'll have the funding.
I'm kind of cracking up at the moment because I'm going through the different comments, and I'm getting the typical, where's your ice wall? Show us pictures of that. Can you Google that? You can see the ice wall. Videos of it too. It goes on and on. Is it Captain Cook that you should be researching, who went thousands of miles trying to find an inlet into it and couldn't do it? Just went in a circle, many thousands of miles. Anyway, that's a little off subject.
He went in a big circle? You don't say. I wonder if his compass kept pointing the same direction too as he went around said circle. All of these things are shocking. You know what? Flat Earth confirmed. Moving along.
In researching, I've been trying to find this calculator that told me exactly what the angle of the sun rays would have to be at 93 million miles, and it's like 89.986. I'd want to know the exact number just to get it again, but I can't find it. But I keep coming across these different beam angles and how much spread there is in the beam. And we've had this discussion about how many actual rays of the sun would strike us at 93 million miles if the sun is a ball, and even 1/4 of a degree off, it would never strike the Earth.
Oh my god, are you serious? Do you lack all ability to think in 3 dimensions? Stay with me here, buddy. The sun puts out light with the same intensity in all directions. It isn't a flashlight, okay? Does a light bulb on your ceiling light up everything like an orb? Of course it does. You don't surmise that the light would miss you because the light travels outward in equal intensity from the source in all directions. So yeah, a lot of light misses Earth. Congratulations, but it doesn't matter because the sun is shining in every single direction, at every single angle. So the spread should always be hitting you at pretty much 90 degrees at high sun if the tilt were appropriate to have you directly facing the sun. Depending on season and where you are on the tilted planet, you may not be getting 90 degrees. Hence the seasons. Hey, let's all give Mr. Thrive and Survive a bit of round of applause here for learning how light bulbs work, right?
And I keep coming back to this, how wide does the beam spread out by distance? I was like, okay, this is probably doing it for, light bulbs and things like that, but does the same thing hold true for the sun? I don't know. I'm throwing it out there. So,
see, this is always the thing. This is their out. I'm just skeptical. I'm just asking questions, guys. But by the way, while I'm at it, here's all these facts that the Earth is so not a globe. But I mean, no, I'm just skeptical. I'm just asking questions. So when you call me an idiot and prove that I'm wrong, I'll just say, oh, but I was just asking questions because, I'm skeptical.
I'm just a globe skeptic, not a flat earther.
How the angle from the light source, the beam spreads out so wide over distance. Well, what if it was 93 million units, and I'm using miles here. What if it was 93 million miles away, and I used 89.96 degrees, so nearly parallel, and you calculate the spot size. How wide does that one little light beam spread out? And the answer is, and I'll have to come up here and paste it because you can't see it here. So I will copy it, and I will grab my thing and pull it up here if I can. I have to wait till it blinks on me. And I'm going to paste it in here. Look at this. It's 185,870,192 miles wide. Why doesn't the sun fill the entire sky?
Yeah, but you can't see light that's not hitting things. I mean, technically you are seeing it fill the entire sky because that blue glow that you get off the atmosphere. You know what? Just... We're going to move on to the next segment because he says some stupid things about the moon, too. So here we go for my new intro into my segment, How Come Moon? Please enjoy.
We'll do it live. Okay. We'll do it live! Morty. Maybe I hate myself. Maybe I think I deserve to die. I don't know.
Proof that the sun is not causing the phases. And it's funny how it always works. Recently, I've been getting comments telling me that the phases of the moon, or how can you explain the phases of the moon if the sun doesn't do it? That's been done in many different videos in the past. But anyway, we're going to show definite proof here it's not the sun. So here's the full moon. Now here's the waning gibbous moon, and this is exactly what we're looking at. Granted, it was the first day after the full moon, so this should be less of a sliver here, but I want you to notice that it's, even when it's this far, we have no farther than halfway up on the moon, or the midpoint of the moon is dark. Same thing for the bottom, correct? And let me see if I can get a picture that's got more days in here so we can see exactly how this normally works. Okay, this is going to be about the best one I can find. This one at the top here is the full moon, and we are going to look at the very next day like we had here. This was the day after, again, the blood moon on the January 21st. Again, I'll zoom in on this one right here. And as we can see, there is, you know, it's not beyond the halfway point where it starts getting dark here on the right side. It tends to be a little bit more towards the top than the bottom, but not by much. Second day, let me move over to this one. Same thing. Again, even the third day, it's not beyond halfway across the moon's surface. All right, now let's go back to the picture that I took from the camera. Okay, actually, I'm going to start with a video. Like I said, I thought I was taking a still picture. And let me do this one right here. Let me see if I can get the properties to pop up here. Of course not what I wanted. All right, this was January 22nd, 2019 at 8:58 p.m. So now you know when it was taken. That was the whole thing. Oh, there it is. There it is. Okay, now notice this from about here all the way around. We have darkness, which makes no sense in the model. Absolutely no sense. Now, I'm not going to get into that. That's what I was actually going to talk about. That it's dark up here. And actually, I'll throw in a little bit of how the orbit is supposed to be, so you can see that why this might be lit from the bottom and not the top. This was, again, in the evening. The sun had set already. And you might say, well, the sun's below the earth, Rich. Of course, it's going to be on the top side that it would get dark. Okay, that's not really right. Not in their model, because the phases are caused of moving left and right for the most part, not north-south.
There is a lot of wonderful to unpack in this chunk, but I'm going to concentrate on his lack of ability to think in 3 dimensions. So this is taken in January when the northern hemisphere is experiencing winter, so we know that the sun is primarily focused on the southern hemisphere. What's interesting about this image is if you imagine a sun below you shining on the other side of a sphere, you would indeed get this pattern. And notice it's even tilted a bit towards the southern for him, indicating that the sun is in fact also in a southern direction to his position on this sphere. But okay, we're wrong about the orbit because it goes left to right, not south to north. Sure, that's correct, but his ability to visualize the 3 dimensions required here isn't very powerful, as this really is very simple. These photos you're referencing are of the moon at high sky, probably from an equatorial position while the moon is directly above you. You, however, are not viewing this from directly below as you're looking towards the horizon for this shot. In fact, that orange glow also shows that light from the Earth is cutting through the atmosphere on the other side, and the blue wavelength of light is not reaching the moon, thus the reddish. So I have an experiment for you. Next time you take the shot, lay on your back with your feet facing south and then turn to the right and take the shot as if you were standing vertically looking out across the same plane the moon path would be on. From left to right, as you stated. Now, what happens to your shot of the moon? Want me to show you? It's really neat.
Magic.
Alright, we need to be wrapping this up, but I have one more tidbit of moon to get to. In my investigating all of this stupid, I found something that just made me laugh on the spot. And then, of course, it was the right time of day, and I was like, let's do this.
Part of the sky, because our theory is that the moon does not rotate when it's full.
but does rotate when it is not. And as soon as it goes into phase, that's when it starts rotating. And here's the interesting thing. Now, I know what the people will say immediately. Well, the Earth is tilted 23¼ degrees, Rich. This is why you can have the sun. See, the sun, this is the path of the sun, this other one here. Or maybe it's the moon. But both of them will follow this path. If the moon is always south of you, and the sun is always south of you, how can it be north of west after it sets? Now, like I said, people are going to say the Earth is tilted. Get a basketball, find the one of the lines on the basketball that goes around, act like that's the equator, tilt it back about 24 degrees, and imagine the sun going around it to your south. When would you ever look north of due west for that sunset, or for that sun? If just imagine you could see through the ball.
All right, we're going to make this one quick. This is what happens when the Earth is tilting, okay? Now, what I want to show you is when the sun is rising for you, because of the fact that you're on a tilted globe and the way that it rotates. Try to stay with me here. I know you're playing with putty in the corner already, and you've already moved on. Like birds, and there's probably a gerbil running by, and just... so excited. Tell me about the rabbits, George. Tell me about the rabbits.
Chick, and we're gonna live off the fatted land, and have rabbits. And have rabbits.
But, stay with me here, Mr. Thrive and Survive, because if you look right here, when the sun is just rising for your ass, and this being east and west, this line here, let's say, what do you think this direction would be if not east or west? Would that be north of east? That is intensely crazy. And you know what? I can back this up with visual confirmation, because what the f is this? Or this from just the other day. I think that's going to be it for me. Thanks for coming, everybody. Please check out my other videos, like, subscribe, and don't forget to stick around, because I'm only about 140, 130 something subs away from covering myself in sugar syrup. And it's happening. And the wasps are out, and that's going to be intense. We haven't drained the pool yet, and I'd like to get there before it gets goddamn cold out, people. So if you could please subscribe, and let's get me covered in something sticky. Who doesn't want to see a sticky beaver, right? Let's face it. Anyways, have a good night, everybody. Take it easy. Bye-bye.